Hey everyone, welcome to this IBDP MAI course, and today we are going to cover this topic 3.3 in SL, which is applications of right and non-right angled triangle, right, using the Pythagoras theorem also, and angles of elevation, angle of depression, and constructing the label diagram for the given statement. Also, we will learn about the bearing angles. Okay, so we are going to cover all these topics in this session. So let's start with angle of elevation and depression. So if there is an observer who is looking above the horizontal level, then it will be angle of elevation, and if he is looking below this horizontal level to his eye, means in that case we will get an angle of depression. I'll show you. See, this is an observer who is looking at the top of a tower here. So from his eye to the top of the tower, this line, we call it line of sight, and the angle made by this line of sight with the horizontal level. Okay, this is horizontal level. This angle is called angle of elevation if he is looking at the top. Similarly, if there is a person, let's say, who is looking at an airplane as well as looking at a dog like this. So this is the observer and this is horizontal level as per his eye. Okay. Now the angle made by the line of sight, this one to the airplane with the horizontal level, means this angle is called angle of elevation. Similarly, the angle here, this one, is called angle of depression. Okay, so in this way we can see the difference between angle of elevation and angle of depression. Now, this question says the angle of depression from the point A, there is an observer standing at point A. From this part, the angle of depression, so this is the horizontal level. Always angle of elevation or depression are always made with horizontal level only. So to the B boat is 15 degree. So this angle is given as 15 degree. Now the cliff is 100-meter high. AC is the cliff, right? And C is the foot of the cliff, as you can see in the diagram. So it's a right angle triangle here. It says find correct to the nearest meter the horizontal distance BC from the foot of the cliff to the boat. This distance. We are looking for BC distance. What we have, let me draw the diagram. We have this angle as 15 degree, which is angle of depression. And similarly, we can say this angle is also coming out as what? 15 degree. Why is that so? See, this is a parallel to the horizontal line. Yes. And this is a transversal line here. So interior angles, right? These two angles are equal because this line, let's call it L1 and L2, are parallel lines. So now for an observer who is standing at, let's say, B, this will be angle of elevation. Okay. Now we need to find the value of CB. We have angle and we have this side line which is opposite side line, and we are looking for the adjacent side line. So we need to look for that trigonometric ratio which gives the relation between opposite and adjacent. Okay, so what is that? Yes, tangent theta. So tangent of the 15 degree will be equal to opposite 100 over adjacent 100 over x. Now we can calculate the value of x right here. Just use the cross multiply, take this to this side, x to other side, simplify for x. We will get x comes out as 373.205, and this is write your answer correct up to the nearest meter. It comes out as 373 meters. Okay, so in this way you can apply the trigonometric ratios in a right angled triangle to calculate either heights or the distances. Okay, next part is bearings. Bearing angles are always calculated from the north side, remember this, in the clockwise direction. Okay, so note these points. A true bearing is always written using the three digits. Like if the bearing angle is 70 degrees, so we write it 070 degrees rather than 70 degree. We use three digits. Next is, let's say this is north. Okay, this is not representing the north direction. A person is standing at A and he's traveling through this and reached some point B. So the angle in the clockwise direction made by this is the bearing angle. This angle is the bearing of B from A, and it is measured from north, always written in 3 digits. And remember this, what is that theta? Theta is bearing of B from A. Now if this says find the bearing of A from B, so again we need to draw this north, this is north, and we are looking for this angle. Okay, so remember these results. Okay, A bearing of A from B or B from A are always differ by 180 degree. The difference will be of 180 degree. Okay, so in this case, if this angle is theta, so bearing of A from B will be 180 plus that theta angle. Okay, we are gonna need these results later. Okay, so now you also know about the sides, right? North, south, east, west. Okay, let's solve a question on this. We have a cyclist rides 21.3 km due west and then 13.8 km due north. To the nearest degree, find the bearing of the finishing point from the starting point. So let's draw a diagram for this. So consider this is east, west, north and south. Okay, so person was standing here, cyclist starts from here and travels rides what 21.3 kilometer due west. So this distance is 21.3 kilometers. Then west to north for 13.8 kilometer. So let's take here, that is 13.8 and reaches at this point. Now it says, if I join these, okay, now it says find to the nearest degree of the bearing. So they are not asking for this angle, no, they are asking for bearing of this, and it is always measured from north. So we need to find this value. Okay, right, we have a right angle triangle over here. So in this right angle triangle, yes, I can easily find the value of this smaller angle, and I know this angle to here, this one is 270 degree. So if I add 270 plus that angle, let's call it theta, yes, I can get the bearing of that final point from the initial point. Okay, so let's solve this one. Here, this is the diagram. Okay, so now let's apply these and find the value of theta. So we have theta. We have to find theta. So we have opposite side and adjacent side. So we need that relation which involves opposite and adjacent. Tangent of theta. Yes. So apply tangent of theta equals 13.8 over 21.3. So use your GDC, that gives you theta value as 32.9 degrees. Now as I said, this total angle is what? This up to this it was 270 degrees, right? 270 plus 32.9 gives me 303 as the uh, bearing from the bearing of the final position from the starting position. Okay, it's in 3 digits. Yes, answer. Next, one more question. Consider this situation. Carmen departs from point A and walks in the direction 55 angle bearing for 8.91 kilometer to X. Okay, let's draw this one first. So consider he starts from, this is north, okay, true north. So from this bearing an angle 55 degree travels to reach the point X and travels a distance of 8.91 kilometer like this. So this angle is 55 degree and reaches at some point X. So this, let's say A to X, the distance is given as 8.91. Okay, so we can draw A and we can draw X. Okay, now this angle is 55 degree as I said, this one, and AX distance is also given as 8.91. Now it says she then changes direction and then walks for 7.29 kilometers course 145 degrees to the point B from X. bearing angle is 145 degree. So this one is more than 90, right? So 145 degree to reach the point B. Here is the point B, and this distance is what? 7.29. Bearing angle, this angle is given as 145 degrees. That's north. Remember this. It's a simple two-dimensional geometry. Okay. We are doing it for a real life based problem, but yes, you can always consider it as a two-dimensional here in this problem. Okay. So next question says, draw the fully labeled sketch of the situation. So if we join AB also, okay. Now, so what we will get? We will get a diagram something looking like this. Okay. Now, let's talk about first part. Draw the fully labeled diagram. Done. Second part. Find the distance of B from A. Means distance of B from A means we are looking for this AB distance. This one. How can I find this distance? For that, let's find the value of this angle. This one. Okay. Let's talk about this angle. What information do we have here? Right? Using those information, we will calculate this value. Okay. So here, second after the second part, we also need to find the bearing of B from A. Bearing of B from A. This angle, let's call it theta. And in the third part, we also have to find the bearing of, if this is true north, bearing of A from B. So we need these three information. Okay. You can pause the video and try this question all by yourself. Okay. Now I'm going to solve this one. So let's start with this angle AXB. What is that? If this total angle is 145 degrees, this one. Okay. And we know if I extend this, that is going to be, if I extend this, 8AX. So this angle is what? 55 degrees, right? So this angle comes out as what? 145 minus 55, which is 90 degrees. So if this is 90 degree, it's a linear pair. So again, this angle comes out as 90, right? I hope this is clear to you. First we extended this. This is 55. This is 145 minus 55, which is 90. And if it is 90, linear pair, use the linear pair. AX is a line, right? So we can get the angle AXB comes out as 90. So it's a right angle triangle. Now if AXB is a right angled triangle in which two side lengths are already known to us, we can use Pythagoras theorem to calculate the value of AB. Okay, so AB squared comes out as square 8.91 squared plus 7.92 squared. From here, AB comes out as 11.51. Now we have the value of AB, 11.51. Means we have all the three side lengths and we have one angle, which is right angle triangle. So we can easily find now the value of theta here. So we have all the side lengths. You can use any relation, sine theta, cosine theta, tangent theta. It's a right angle triangle, right? So if we use tan theta corresponding to, in the triangle AXB, remember, AXB, okay? So theta is the required angle, which is the bearing of B from A. Okay, so tan theta is opposite upon adjacent. Opposite is 7.29 and the adjacent side, what is that? Adjacent side is 8.91 because AB is hypotenuse. So from here we can get the value of theta. Yes. So let's calculate the theta, which is arctan of 7.29 over 8.91 comes out as 39.3 degrees. Okay. If it is 39.3 here, we got the value of this angle theta as 39.3. Now we need bearing of A from B. So this is north. We are looking for this angle. You remember in the beginning I gave you a result. These are differ by, yes, 180 degrees. So the value of this fourth part means the bearing of A from B will be 39 plus 180, right? So that gives me what? Sorry, wait. 39 degrees is the tan theta. We are looking for bearing. So bearing measured from north. So we need to add these two, both of these angles. So that gives me 39.3 plus 55. Okay, makes what? 94.3 degrees. Now using this, we can find the angle, this one. What is that? 94.3 plus 180 degrees. That gives me 274.3 degrees value. Okay, so that's it. So in this way, we can calculate the bearing angle, missing side lengths, even if it is a right angle triangle or not. Okay, so bearing angles are complete. So that's it for today, and we have covered applications of trigonometry for finding the heights and distances, and as well as constructing the diagram, finding the bearing angles. Okay, so that's it for today, and thank you for watching this. See you all in the next session. You can try this question all by yourself. Bye bye. Have a good day.